Hello, and welcome to the Key Stage 4 chemistry topic, Pure Substances and Formulations. Before we get started, can you please make sure you have a pen, paper, pencil, ruler, and a highlighter or another coloured pen or pencil for self-assessment as we're going through this recording. Can you also make sure you're in a nice quiet room with the correct equipment and so there's no distractions from this recording. Can you pause the recording just for 10 seconds and get down learning objective to understand the difference between pure substances and formulations? Okay, going to start off with retrieval practice first. Can you pause the recording for 5 minutes and have a go at these 4 questions? So pause the video, 5 minutes, go. Okay, you're 5 minutes up there, guys. Can you please make sure you've got another coloured pen or pencil to self-assess this and give yourself a mark out of 4 as we're going through. So, question 1, what is fractional distillation? Well, the definition of fractional distillation is the separation of a mixture, so a crude oil hydrocarbon, remember that's hydrogen and carbon together as a long chain polymer, into its fractions according to different boiling points. Give yourself a mark if you got that. Question 2, the functional group of an alkene is of course C double bond, in particular double bond between the 2 carbon atoms. Question 3, what is cracking? Well, cracking is simply the long chain hydrocarbon is broken down using heat into an alkane and an alkene. And that using heat is thermal decomposition, so breaking substance down using heat. And question 4, what is always made when an alkane goes through cracking, the process of cracking? It is a smaller alkane, so a much smaller alkane, and then alkene. Give yourself a mark out of 4 there, guys. Excellent if you got 4, 3 well done, 2 good, 1 let's focus on the improvements there. Okay, so what we're going to learn about today, we're going to define pure substances and understand what formulations are, and then justify why substances are either pure or a formulation based on information provided and given. So, just want you to have a little think on your own. What does the word pure mean? So have a think, give yourselves 30 seconds, jot down any ideas. What does pure mean? So pause video, go. Okay, so hopefully you've got the idea of what pure means. So pure orange juice would mean that it's not only orange juice and it is nothing else. But if you're a chemist and you're working in a laboratory or a scientific background, it would not certainly be considered pure because inside orange juice you've got the pulp, you've got the different types of vitamins, you've got the different types of water as well, and the liquids that mix it. So it is not technically pure. In advertising it means nothing has been added to it or is it fresh. But in science, in chemistry, a pure substance is one that is made up of just one substance. That substance can be either an element or a compound. For example, oxygen is a pure element because it is only made of the element oxygen. Compound, so it could be water. So H2O is pure because it's only made of compounds. But if you add seawater, that's water with different compounds and different elements in it as well. So that is not pure. So can you make sure you got that definition down? Okay, so for example here, this is a pure element because it's all one type of atom. We have a mixture here because you have different compounds and a mixture of some elements as well. So this is not pure, this is a mixture. This is a pure compound, so this is pure compound because there's each atom. So NaCl, this could be 1 sodium, 1 chlorine, because even though they're different atoms, they are all the same compound, so it is a pure compound. A pure element here, so this is pure because it's all magnesium, and those examples there. So, just a bit of a recap here from the separating mixtures. So a mixture, obviously, is 2 or more elements or compounds. They are not chemically joined together, so we can separate them using these 4 techniques. So chromatography, distillation, filtration, and evaporation. Now this is a recap of chemistry paper 1. So what I want to do is pause the video for 4 minutes, write in the definitions and then join them up to the correct separating mixture technique. So write them in as they are, join them up, you have 4 minutes, go. So your 4 minutes up there, guys. Can you please make sure you've got a green pen or another coloured pen or pencil to self-assess it? So chromatography, that's simply just separates liquids of different colours. So that is the third one here. So just this one. Distillation, that separates liquids with different boiling points. So you could have a mixture of two different liquids, ethanol and water. Because water has a lower boiling point, it will boil first, and then you can condense it and separate it out into liquid of only water. Filtration is the example here at the bottom. So separates a solid that can dissolve from one that can't. So for example, if you want to separate a mixture of salt water and sand, the sand will not pass through because it is not dissolved, but the salt will because it is dissolved, it is soluble. And then the last one, evaporation or crystallization, can be referred to, separates a liquid and a solid by boiling off the liquid, leaving only the solid behind in the evaporating dish. Give yourself a mark out of 4 there, guys, and then we'll move on. Okay, so on this screen here, we have 4 different diagrams of the 4 techniques separating mixtures below there. So what I want to do is just label them. So the top left being 1, then right 2, 3, and 4. And then can you tell me which technique they are? So using the 4 previous ones on the previous slide, can you tell me what 4 they are? Pause the video for 2 minutes and have a go. Okay, the answers will quickly come up here, guys. So the first one is chromatography, because you're identifying the different inks and using chromatography paper. Distillation, because you're heating up a mixture of the liquids and you're condensing it using here to separate into just a single pure liquid. Then we have evaporation or crystallization, and then filtration because of the filter paper and filter funnel there. Give yourself a mark out of 4 again, guys, and then we'll move on. So, pure water, you can use melting and boiling to identify the pure substances. The melting and boiling points of an element or compound are what's called its fixed points. We know water boils at 100 degrees Celsius and freezes at 0 degrees Celsius, so these are its fixed points. A liquid was tested for purity. It had a boiling point of between 106 to 111 degrees Celsius. What does this tell you about the liquid? Well, compared to water, it has a few more impurities in it, and these impurities can affect its fixed points of boiling and freezing points. So, pure substances, so gold and pure water are examples of pure substances, gold being the example element and pure water the compound. So, what I want to do is just pause the video from recapping what we've done and then write your own definition of a pure substance from what we've done so far, and then as an extension, is milk a pure substance? So have a think, is milk a pure substance as an extension? I'll give you 4 minutes for that. 4 minutes, have a go, now. Okay, going to quickly go through these as well, guys. Can you make sure you got a green pen or another coloured pen and pencil to self-assess this? So a known definition of a pure substance is a single element or compound not mixed with any other substance, in particular a single element or compound there. And then, is milk a pure substance? Well, in science, no, because it's a mixture. In everyday use, though, as it has, yes, because it has nothing else added to it, it is only just milk. But in terms of science, no, it's a mixture of water and different minerals and vitamins. Okay guys, your next little task here, I just want you to read through the 2 bullet points on top there, so pure substances and pure substances, and then have a go at these 2 questions there. So relevant to there and what we've done today, can you please answer the 2 questions at the bottom after reading the first 2 bullet points? Can you pause the video for 5 minutes, and have a go at the 2 questions? Okay, your 5 minutes are up there, guys. Can you make sure we self-assess this in another colored pen or pencil? So the first question is just asking, why is salt used to grit the roads? Well, salt decreases the melting point of the ice, so it means that the ice becomes water as it would need to be colder to remain ice. And then question 2, what would you expect to see when salt is added to a pan of water that has just started boiling? The salt would increase the boiling point of the salt water solution, so the solution would stop boiling. So give yourself a mark out 2 for that, guys, and then we'll move on. So mixtures, though, are different to pure substances in how they affect the melting and boiling points. Melting point and boiling point in a mixture will vary depending on composition of the mixture, so it can vary, it can change. A mixture does not have a sharp melting point or boiling point, it changes state over a range of temperatures, so it's not instantaneous at 100 degrees or 0 degrees, it can take place over 0.5 to 1 or 2 degrees Celsius. Impurities, so those are, if for example in mixtures, those are different elements, different compounds that are different to the original element, tend to lower the melting point of a substance and raise the boiling point, so key point there. The purer the compound, the smaller the deviation from the actual value of the pure substance, the actual value there. Bit of key information right there for you. Okay, coming towards the end of the lesson recording so far. So what I'm going to do is a quick progress check. I'm just going to read through the question and then you're going to have a go yourselves. So Sam and Alex each made a sample of the same substance. It is unknown at the moment. They measured the melting point. They then recrystallized, so make it into a solid. They're solid, and then measured the melting point again. They did this several times, so repeated the experiment. Who made the purest sample and why? Give a reason why, and this is 3 marks. So look at the data below, analyze the data, compare the data of both Sam and Alex, and then we'll go through this, and it's 3 marks. I will give you 5 minutes for this, guys. So 5 minutes, pause the video, go. Okay, your time's up there, guys. Your answers will come up. Can you please make sure you give yourself a mark out of 3? So, hopefully you got that Sam created the purest substance in particular, and this was identified because the melting point was almost the same for each one test, individual test. The highest was 46.7, the lowest was 46.5, so very accurate and precise there. And then the melting point was higher than Alex's results, e.g., for example, the highest for Alex was 45.1 compared to the highest of 46.7. So give yourself a mark there out of 3. Make sure you compared Sam's and Alex's data in particular to get the full 3 marks. Okay, so we're moving on to the final part of this recorded lesson on formulations. So this includes fuels, cleaning agents, paints, medicines, alloys, metal alloys, so it's metal and non-metal combined together, like carbon and fiber, fertilizers and foods. So the definition of a formulation is here now, the AQA definition. Can you please make sure you get that down? So pause the video. Now, a useful product could be defined as fertilizers, in particular because they're made up of nitrogen, phosphorus and potassium to help plant growth, or key medicines with active ingredients that are used to treat illnesses, in particular relevant these days with the coronavirus vaccine that's been outrolled this year. And they also need to be quality ensured, so all medicines need to be quality assured to make sure they are safe to consume. That concludes the video on pure substances and formulations. Thank you for listening. Take care.